So good job from what you guys have done so far. I think these things are really important that we take note of them, and we're very much aware when we say IPv4 is 32 bits, right? We've also broken down bits being the smallest point of measurement. It's just zeros and ones, right? And now we said IPv4 is a 32-bit network, so that's it has 4 octets. So each of these octets makes 8 bits, right? So, and we made very important, we really cleared out a lot of things. Like taking for instance here now where we do our, when you're maybe doing your conversion from decimal to binary, we use this decimal number. When you're doing your conversion from decimal to binary, like we did here, and we had 101, because it's a network, an IPv4 network, and it's 8 bits, you have to fill up the other parts that are missing with zeros. And of course, this formula here would actually really help a lot in whatever we're doing, right? And like you see, that was exactly what we used in attempting to get the octet of these networks, right? And we can just keep going on and on and on. And we also did conversion from binary to hexadecimal, which you guys did very well in your notebooks. So why this thing is very important is because we're going to be moving into something very important. Like, that's really, I wanted us to touch this, so it's really going to help you understand the subnet concept that we've been talking about. Who can remind us what is a subnet? So you can do a quick Google search. What's a subnet? Subnet mask. What's a subnet mask? Do that quick Googling. So that, what's a subnet mask? Once you're there, you just say it out. What's a subnet mask? Okay, calculating and manipulating IP addresses to determine which part is going to network and which part is going to the host, right? So, and one last thing before I forget, look at this point we mentioned here earlier, right? And when we're trying to talk about how many the reason for IPv4 and IPv6, right? So to get that, you see that IPv4 network addresses is only about approximately 4.3 billion, right? Because we are counting the total number of bits which you have in an IPv4 network, which is 32. So 2 raised to the power of 32 will give you 2.3 billion, right? And then IPv6, on the other hand, is more of like a 128-bit network, and it's hexadecimal, right? We can say something like this can be IPv6. I'm just trying to sketch a little random 390B. So it just keeps going on and on and on. And I want us to take note of these parts, right? Just like here, it's more like, have 4 octets. In the IPv6, we have 8, right? And each of them here is what? How many did we say initially? 16 bits. So they are hexadecimal. And of course, you know hexadecimal is 16. So they are 16 bits. So 1, 2, 3, 4. Okay. So we need like 4 more. So I can decide to just give 0, 0, 0, 0. 0, 0, 0, 0. 0, 0, 0, 0. So this could literally how an IPv6 address could be. Now imagine when you're having 2 raised to the power of 128, right? So there is literally a lot of addresses. I think that I don't know the number, but it's going to be high. When we did our calculation, we got exponential what again? 38, right? So, and why IPv6 came about back in 1999 is because to prevent so that everybody can always have access to the internet, to networks, right? Because IPv4 is diminishing. Over the 4.3 billion networks could easily be exhausted, especially the more and more devices connects, right? And now we said, back to what we want to talk about in subnet mask, right? Subnet masks. So subnet masks, I think there is something else we need to know before subnet masks. What's that thing? We were talking something about around prefixes initially, right? Like if I give an IP address, say I say 10.25.5. So well, we know I said a lot of things about prefixes. So we're going to look at that. Now this is one. And then let's take another one. Let's say 150.10.8. And I do this at let's say, let me just call this 16. So surely you know that when you see this, right? Remember, IPv4 is how many bits? 32, right? So surely anything you see in this range, you know that, of course, it is a IPv4 address. But once you begin seeing a prefix like this, what address is this? That's IPv6. You've crossed IPv4. So now we are talking about subnetting, right? Now, for this now, the prefix of 24, what does it say? It's trying to say that, you know, each octet is 8 bits. So each of these octets is full in the subnetting. So here is full. This 8, right? Plus 8. 16 plus 8. 24. Right? So you see that the subnet max for this network would be 255.255.255.0. That's the subnet max of this network. I think I can wipe here so that we explain this much better. So let me clean this here. Let's solve it above, right? For 1, we have 10.10.25.5. So now this is what? 255.255.255.5. Oh, sorry, .0. Because that octet is not being used. And now, yeah, something also important to note would be that this right here is what? Our IP address. And this right here is what? Our subnet max. Now, to get our network ID, sorry, I feel I should shift this a little bit. Let me make it neater. 10.10.25.5. Then that's the IP, right? Subnet max will be 255.255.255.0. Now, there's what we call let's call this the NID. That's network ID. Remember, we're saying something around loop back and broadcast, right? And I think I gave a formula yesterday when we were introducing this. So I'm going to need that formula. But before that, how many of us remembers our AND gate? AND gate, OR gate, basic secondary school stuff, right? So we'll be working with the AND gate here now, right? Don't be scared. It's not that much of a big deal. What AND gate simply means, right, is that when you have, let's say you have value A and B, you want to find the AND of them, right? This one is 1, 0, 1, 1. This one is 1, 1, 0, 1, right? What AND entails is that both of them has to be true. You know, or says if either of them is true, then the result is true. For AND, both has to be true for it to be true. So here, so what will be the answer for this? AND will be here. 1, 1 would be what? What would it return? 1. 0, 1. Off and on will return what? Off. Off and on and off. Off. On and on. They both have to be true. That's when you're solving for AND gate, right? And now, back to this thing we are talking about here, right? I have to clean this again. So we're just going to find the IP addresses of this. I said IP addresses. We're going to do, don't worry, let me just do it. 10, 25, 5, right? I want us to get their bits value, their binary, using this quick format. What do we get? Remember, this is 2 raised to power 7. This is our 8 bits. 2 raised to power 6, 2 raised to power 5, 2 raised to power 4, 2 raised to power 3, 2 raised to power 2, 2 raised to power 1, 2 raised to power 0, and 0. Right? That's how we got this. It's a very faster way to solve for binary. Now, we want to get the binary of 10. What two numbers will give us 10? 8 and 2, correct? So now we are going to on those two. And then the others that we didn't work with would all be what? Zeros. Now we're having that's for, oh, let me just shift this a bit inside. And the same thing for here, right? Then now for 25, we want to solve for 25. 16 plus 8 is what? You said? The number is more than 8 for 10, right? 1. Okay, yes. Thank you very much. You are very correct. Yes, thank you for that. We don't need that, yes. We don't even need that here. I'm just putting this here for... 16 plus 8 is what? 24. So we are just getting one more, right? So 16 plus 8, 24 plus 1, right? So this is 25, right? So we are turning off the others. Right? So we have 0011, 001, 0011, 001, 00, 0. And then for 5, 4 and 1, right? Sorry. So we have 0000, 101. 10045. Now for our subnet max, we'll do the same thing for our subnet max, right? We'll do the same thing for our subnet max. So remember, we said 255, right? So 255 would mean adding up all of this. 128 plus, okay, let's go. 128 plus 64. 192 plus 32. 224. Plus 16, 240 plus 8, 248 plus 4, 252 plus 2, 254 plus 1. You see? So to get to 55, we have complete ones in our 8 bits. Right? Remember, this is 255, 255. The last one is 0. So what would this one be? 0 all true, right? Now we want to get our network ID. So remember, we are doing what? We are using the AND gate, right? So 1 and 0 is what? 0. So all this would be 0, 0, 0. 1 and 1, 1. 0, 1 and 1. So same thing, 0, 0, 0, 0. 1 and 1. I think same thing here. 1, 1. 0, 0, 1. And now, what would here be? 0, 0, 0, 0, 0. 1 and 0. So they are all zeros, right? And that's because we have 0 here. Remember, this is 255, 255, 255, 0. So that's really what we have at this moment. Please cut the video first. Okay, catch my. So yes, and recall this is our network ID. And if you look at this, like this is same IP address, right? The only difference is at the ending, right? So you see it's still here, below would still be 10, 10, 25. What would be here now? 0. You see, initially we were saying something that there are some there is an IP address that you cannot use. So that one now is mainly for the network. That's what the network would use. So you cannot assign this IP address. If you want to assign an IP address, you start from 1 and go. But this .0, you can't touch it, right? And now, what other thing? Okay, we're solving the subnet max, right? You also have to note that this 0 that is here now, this 0 that is here, this is like complete 8 bits of 0. You know that, right? It's like complete 8 bits of 0. So imagine here now that this is still like 255, 255, 255, 0, right? 2 raised to power 8 is what? 256. Okay. Now, okay. 256. Remember, from this thing you solved the other time. Yeah. Yeah, exactly. So now, to solve for this, this simple formula now here is just 2n minus 2, right? So 256, this already now. So 256 minus 2. What does that give us? 254. All right, so we have IP address to play with from 1, that's from 10.10.25.1 down to what? 254. We cannot touch 255. Why? 255 is for broadcast, right? 255 is for broadcast. So you see that we've been able to see how you can use a subnet and assign IP addresses. So you see that the IP address could now look like, when you're assigning IP address to the host devices, to look something like 10.10.25.1. This will be the first IP address you are assigning. 10.10.25.254. Right? So 255 is for what? Broadcast. .0 is for what? The network. Right? So I think this is basically, solving for, subnet, trying to share those network IPs. And I know we looked at something cooler too the other time. I think I did a formula around, what was the main formula I gave the other time again? Let me see or no. think it was 32 minus prefix.
Yes.
32 minus prefix minus 2. 32 minus prefix minus 2. So even using this is still very much accurate. What's our prefix here? 24. Now see 32 minus 32 minus 4. 32 minus 24 minus 2. 32 minus 24 is what? 8.
Yes.
Right? Minus 2. No. 2 raised to power minus 8. 2 raised to power 8 now. That is this. 256 minus 2. Right. So I think that's really how subnet max works. I hope it was very exciting. So what's going to happen is constant practice, you'll get better, right? So I want you to attempt this. I don't know. I want you to attempt this using all what we've solved and worked with. I want you to attempt this for yourself. It's also going to help you understand it better. Eh? Yes, this one. I want you to solve for this 16. No problem now. It's still fine. So hopefully from tomorrow we should also begin even exploring working with the Cisco packet tracer, right? So although maybe tomorrow what we will do is to work on more examples on subnet max so that it kind of like sticks. If you can, I would also advise you get to work on this now that it's actually fresh in your mind, right? Because when you say you want to take it home, you'll be looking at your you'll be looking at your scribbles and you're like, and what did I do here? So now that it's still fresh in your mind, trying to use it to do yourself. Because what's still going to happen tomorrow, we'll work on like 5 more exercises tomorrow to ensure that yes, it actually sticks. But if you're in a hurry, you need to be somewhere, then it's understandable. So yes, thank you so much for the class. See you next class.